Hi, my name's John Sewell. I'm doing this video as part of an educational neuroscience master's degree, and this particular part is related to neuro leadership. I'm particularly interested in brain-based teaching and learning. How do we use what we know about the brain in order to teach better and have our students learn better? There's a few points here in terms of what I see as the current situations. Mostly it's the fact that teachers are not trained in how the brain works. I'm going to go through some of the basic parts of the brain that are important for learning. It's probably good to refer back to this diagram as we go through the next section. So here is the list of the particular bits of the brain that we're going to pay attention to. The basal ganglia is considered the habit center of the brain, activated when things are routine, which often happens in a classroom. It's not active when students feel threatened, at which point routine is difficult to manage. It's important in acquiring habits. The amygdala is extremely important for teachers and for students. It means almond, and it's about the size of an almond or a pair of almonds actually. It's activated when things are not routine or when things change. It's activated when we're either in the reward state or in the threat state, if we feel stressed or threatened. It originates the fight-flight reaction, which we don't particularly want in a classroom. It's activated when students are in survival mode, at which point students cannot learn. The reward state motivates students to do more of the same, feel that they've achieved something good or had an aha moment, which is what we always want. The reward state also produces the pleasure hormone and neurotransmitter dopamine, important in making neural connections. It attaches emotional significance to memories. If we can activate the amygdala when we're teaching, we're doing well and the students will feel good, unless we activate the threat mode, of course. The RAS is very important in working out what the brain will actually pay attention to. It filters out things that are unimportant at the time. For teachers, the RAS is activated by novelty. The hippocampus is a most important part of the brain and very important in the formation of long-term memory. Once stimuli get past the reticular activating system, they're examined by the hippocampus. Are they important? Are they worth remembering? Are they worth expending energy on? If an event is repeated, it must be important, hence the importance of repetition. This starts an interplay between the neocortex and the hippocampus, which results in memories being formed in long-term memory. The hippocampus has 27 different types of neurons and is very important in processing memory. It's also important in sleep because there's an interplay with the hippocampus during deep sleep, which will replay many of the things that the person has been thinking about prior to going to sleep. The prefrontal cortex is very important for the regulation of emotion, for planning, problem solving. It's open to higher order thinking and learning, very important for long-term memory. It uses a lot of energy and it's actually not very developed in teenagers, not until about the age of 25, although it's not fully developed then either and continues developing through most of our life. It's a complex part of the cognitive system and important for long-term memory. So what does all this mean for teachers? This is a neuron, and it's considered that there are upwards of 100 billion neurons in the brain, and these making upwards of 100 trillion connections between other neurons. When learning occurs, a number of things happen. The myelin sheath that you can see there actually thickens, and that causes better connections between other neurons, forming neuronal networks in the brain. This actually forms the white matter of the brain. The cell bodies themselves form the grey matter of the brain. The important thing is that when the students learn, the brain grows. And conversely, when they don't learn or when they refuse to do a task, the brain doesn't grow. Here we see a message traveling along a neuron into a second neuron, a receiving neuron, and where the message is passed along is at the synapse. One of the things noted earlier was that the amygdala is the reward center of the brain. And when a student feels pleasure or feels rewarded, they produce dopamine, which is a pleasure hormone, so it makes them feel good. But more than that, it's also a neurotransmitter. It transmits the message from one neuron to the next. Dopamine is the main neurotransmitter that actually transmits signals as we learn. It's important to note that long-term memory doesn't occur unless we choose to make it occur. Students have to intend to learn, and teachers have to intend for their students to learn. The dopamine neurotransmitter is produced when students are in the reward state and feeling good about themselves. It's a key neurotransmitter when learning is occurring. Repetition strengthens neuro connections and actually causes learning to occur better. Now, because the brain is largely a social organ, predominantly, some people say only, students need social connections more than anything else. We often counter that by some of our rules and regulations in a classroom. The cognitive function of the brain occurs when the social brain is activated. Now, another important point is that students learn better when ideas are integrated in chunks and get into long-term memory together. So the key question, given all of that, is what classroom practices support learning? One of the things I'm doing now, which I haven't done for 50 years, is to try to activate the social brain. So my classes generally starting with some social activity, and here's a few suggestions of what you can do. Now I teach mainly 9 to 12, so it's possibly a bit different from other years. But I'll often do a quick quiz where students discuss answers with a friend and don't record the marks of those quizzes to take away any threat. I have them discuss maybe 3 things that they learned from the previous lesson and report back. Or I have them go and tell somebody what they did related to science the night before. Well, I'm trying as well, and what some of my colleagues are trying is dependent upon the primacy and recency effect. The primacy effect is that students will recall most of what happens early in the lesson, not in the middle of the lesson. And the recency effect is that they'll learn what they did last in a lesson. So it's important for the first and last part of a lesson to be the parts where most of the content is placed, and the middle part maybe some activities. Another part which is incredibly important is that students need to know that effort matters most, and that they have the ability to rewire their brains to make themselves better learners. Teachers have got to believe that about their students. Sometimes teachers have a fixed mindset about their students. We often worry about students having a fixed mindset, but we probably need to spend a bit more time and pay a bit more attention to the fact that teachers often have a fixed mindset. Because repetition is really important for the brain to get information into long-term memory and not discard that, then frequent formative low-stakes assessments of learning are really very important. Now, one of the important bits about those frequent tests is that you're using repetition, and repetition will ultimately help to get things into the long-term memory. Now, I've used chunking for many, many years, and I picked that idea up probably 40 years ago in doing an education course. But in terms of the brain, neurons that wire together fire together. So if you can chunk important ideas together, then students will recall those important ideas together. I think this is really important, particularly when students are writing small essays in order to get a whole lot of ideas that they can put into those small essays. I've just got some examples here of some of the chunking that I do with Year 12 physics. Now, this is a very difficult module, and so I chunk together ideas and teach in those chunks so kids get used to seeing those chunks and remembering them. No, I think these things can be implemented in schools. If you get the commitment of a principal and executive staff, that can easily impact on a whole school. You can have a focus group interested in research and evidence-based pedagogy that can promote change. We're doing that in my current school at the moment. Or you can do small implementations of research-based ideas in classes, and it's an effective way of introducing brain-wise research into a school community. Thank you.